Humidity. Dew point temperature is the temperature to which air must be cooled at constant pressure to reach saturation. The dew point lapse rate is 0.5 degree per 1,000 feet. Relative humidity is expressed as the amount of water vapour present in a volume of air divided by the maximum amount of water vapour that volume of air can hold. Air that has a relative humidity of less than 100% is considered to be dry. For example, a relative humidity of 99.9%, the air is still considered to be dry. A relative humidity of 100% is saturated air. Relative humidity is the ratio between the actual mixing ratio and the saturation mixing ratio multiplied by 100. Lapse rates. The dry adiabatic lapse rate is the lapse rate for rising dry air. It's 3 degrees per 1,000 feet or 1 degree per 100 meters. The isoenvironmental lapse rate is known as the isolapse rate and is the average of all actual lapse rates. It's 1.98 degrees Celsius per 1,000 feet or approximately 0.65 degrees per 100 meters. The saturated adiabatic lapse rate is different around the world. It's the lapse rate for rising saturated air with 100% relative humidity and varies depending on how much water there is in the air. For example, in Central Europe it's 1.8 degrees per 1,000 feet, 0.6 per 100 meters. But at the poles or high altitude where the air is drier, it's 3 degrees per 1,000 feet or 1 degree per 100 meters. Whereas at the tropics, where the air is wetter, it's 1 degree per 1,000 feet or 0.33 per 100 meters. This is because latent heat can be released to warm the air, thus decrease the lapse rate. Constable or conditionally unstable. This is a method of determining whether a parcel of air is stable, conditionally unstable, or absolutely unstable. The dividing lines are the saturated adiabatic lapse rate and the dry adiabatic lapse rate. Anything below the saturated adiabatic lapse rate will be stable. Anything above the dry adiabatic lapse rate of 3 degrees per 1,000 feet will be unstable. And anything between the two lapse rates will be conditionally unstable.